National Electrical Code Section 310.4 addresses the use of parallel conductors. A key requirement within this section states that when parallel conductors are run in separate raceways or cables, those raceways or cables must exhibit the same physical characteristics. This provision aims to ensure consistent electrical and thermal performance across all parallel paths. The question arises regarding a specific scenario where parallel polyvinyl chloride, or PVC, conduits are used, but one of these conduits requires a short section of flexible metal conduit to facilitate entry into a switchboard. The core concern is whether this necessitates the introduction of a similar flexible metal conduit section in all parallel PVC conduits to maintain uniformity, or if the presence of any metal conduit violates the code requirement given the material difference between PVC and metal. The National Electrical Code mandates that all raceways or cables containing parallel conductors be constructed from the same material. This is to ensure consistent physical characteristics among them. When one of the PVC conduits necessitates a short segment of flexible metal conduit to connect to a switchboard, all parallel conduits should similarly incorporate a matching segment of flexible metal conduit. The rationale behind this requirement is that dissimilar materials exhibit varying physical properties. These properties include, but are not limited to, heat resistance and chemical resistance. Introducing different materials within a parallel conductor system can lead to a potentially hazardous situation. To elaborate on the implications of using different materials, consider the following aspects. Firstly, impedance differences. Different conduit materials possess different impedance characteristics. Impedance refers to the total opposition a circuit presents to alternating current. It's a combination of resistance and reactance. When using parallel conductors, it is crucial that each conductor carries its fair share of the current. If the conduits have different impedance values, one conductor might carry more current than the others, which can cause overheating and potentially lead to a fire. Secondly, heat dissipation. Different materials have different thermal conductivity properties. For example, metal conduits typically dissipate heat more effectively than PVC conduits. If parallel conductors are run in different types of conduits, some conductors might overheat while others remain cooler. This uneven heat distribution can degrade the insulation of the conductors and reduce their lifespan. Thirdly, expansion and contraction. Different materials expand and contract at different rates in response to temperature changes. If parallel conductors are run in different types of conduits, the different expansion and contraction rates can create stress on the conductors and their terminations. This stress can lead to loose connections and potentially cause arcing or other electrical faults. Fourthly, corrosion. Different materials have different resistance to corrosion. If parallel conductors are run in different types of conduits, some conductors might be more susceptible to corrosion than others. Corrosion can increase the resistance of the conductors and lead to overheating and potential failures. Therefore, to comply with National Electrical Code Section 310.4 and ensure the safety and reliability of the electrical system, it is crucial to maintain uniformity in the physical characteristics of all raceways or cables containing parallel conductors. This means using the same type of material for all conduits, even if it requires adding a short section of flexible metal conduit to all parallel runs to match the one that needs it for connection to the switchboard. In the context of the initial scenario, where one of the PVC conduits needs a section of flexible metal conduit to enter the switchboard, the code interpretation necessitates that all parallel PVC conduits include a similar section of flexible metal conduit. This measure ensures that all raceways maintain consistent physical characteristics, specifically addressing concerns related to heat resistance and chemical resistance. Using dissimilar materials introduces the risk of creating hazardous conditions due to variations in how each material responds to environmental factors and electrical loads. It's essential to delve into the specific characteristics that differentiate PVC and flexible metal conduit to fully appreciate the potential issues. PVC conduit is known for its resistance to corrosion, non-conductivity, and ease of installation. However, it has a low heat resistance compared to metal conduits and can become brittle over time when exposed to ultraviolet or UV radiation. Flexible metal conduit, on the other hand, offers excellent mechanical protection and can withstand higher temperatures. However, it is more susceptible to corrosion, especially in damp or chemical-rich environments. Moreover, metal conduits are conductive, which can present grounding and bonding challenges if not properly addressed. Given these differences, mixing PVC and flexible metal conduit in parallel runs can lead to uneven heat distribution, variations in ground fault current paths, and differential expansion and contraction rates. These factors can compromise the integrity and safety of the electrical system. To avoid these potential hazards, the National Electrical Code requires that all parallel raceways be of the same material. This ensures that all conductors experience similar operating conditions and that the overall system performs reliably. In practical terms, this means that if a section of flexible metal conduit is required for one of the parallel runs, then all other parallel runs must also include a similar section. This approach maintains uniformity and minimizes the risk of adverse effects due to material differences. It's important to note that while adding a section of flexible metal conduit to all parallel runs may seem like an unnecessary expense or effort, it is a critical safety measure that ensures compliance with the National Electrical Code and protects against potential hazards. Ignoring this requirement can lead to serious consequences, including equipment damage, electrical fires, and personal injury. In addition to the material requirements, there are other important considerations when installing parallel conductors. These include conductor sizing, ampacity adjustment, and proper termination techniques. All of these factors must be carefully considered to ensure that the parallel conductor system operates safely and effectively. For example, the conductors must be sized appropriately to handle the expected load current. The ampacity of the conductors must be adjusted based on the number of conductors in a raceway and the ambient temperature. And the conductors must be properly terminated to ensure good electrical connections and prevent overheating. Furthermore, it's essential to consult with a qualified electrical engineer or inspector to ensure that the parallel conductor installation meets all applicable code requirements and industry standards. These professionals can provide valuable guidance and expertise to help ensure the safety and reliability of the electrical system. In summary, National Electrical Code Section 310.4 requires that all parallel raceways be of the same material to ensure consistent physical characteristics and prevent potential hazards. If a section of flexible metal conduit is required for one of the parallel runs, then all other parallel runs must also include a similar section. This approach maintains uniformity and minimizes the risk of adverse effects due to material differences. In addition to the material requirements, there are other important considerations when installing parallel conductors, including conductor sizing, ampacity adjustment, and proper termination techniques. Consulting with a qualified electrical engineer or inspector is highly recommended to ensure compliance with all applicable code requirements and industry standards. To further clarify the requirements of National Electrical Code Section 310.4, it's helpful to examine some examples of compliant and non-compliant installations. Firstly, compliant installation example. A service entrance consists of 3 sets of 500 0 kc mil copper conductors run in parallel from the transformer to the main distribution panel. Each set of conductors is installed in a separate 4-inch rigid metal conduit, or RMC. All 3 RMC conduits are of the same material and size, and they are installed in a similar manner. This installation complies with National Electrical Code Section 310.4 because all parallel raceways are of the same material and have the same physical characteristics. Secondly, non-compliant installation example. A feeder circuit consists of 2 sets of 3/0 aluminum conductors run in parallel from a generator to a transfer switch. One set of conductors is installed in a 3-inch electrical metallic tubing, or IMT, conduit, while the other set is installed in a 3-inch PVC conduit. This installation does not comply with National Electrical Code Section 310.4 because the parallel raceways are not of the same material. The EMT conduit is metal, while the PVC conduit is plastic. This difference in material can lead to uneven heat distribution, variations in ground fault current paths, and differential expansion and contraction rates which can compromise the integrity and safety of the electrical system. Thirdly, compliant installation example with flexible metal conduit. A branch circuit consists of two sets of number 12 American wire gauge or oak copper conductors run in parallel from a circuit breaker to a receptacle outlet. Each set of conductors is installed in a separate 3/4-inch PVC conduit. However, due to physical constraints, one of the PVC conduits requires a short section of 3/4-inch flexible metal conduit to connect to the receptacle outlet. To comply with National Electrical Code Section 310.4, a similar section of 3/4-inch flexible metal conduit is also installed in the other PVC conduit, even though it is not physically required. This installation complies with National Electrical Code Section 310.4 because all parallel raceways have the same physical characteristics. Although the majority of the raceways are PVC conduit, the addition of the flexible metal conduit sections ensures that all raceways are effectively a hybrid of PVC and flexible metal conduit. This maintains uniformity and minimizes the risk of adverse effects due to material differences. To reinforce the importance of adhering to National Electrical Code Section 310.4, consider the potential consequences of non-compliance. Firstly, overheating. As mentioned earlier, using different conduit materials can lead to uneven heat distribution. If one conduit material has a higher thermal resistance than the other, the conductors in that conduit will tend to run hotter. This can degrade the insulation of the conductors, reduce their lifespan, and potentially lead to insulation failure, which can cause short circuits and electrical fires. Secondly, voltage drop. Different conduit materials can also affect the voltage drop in the circuit. Voltage drop is the reduction in voltage that occurs as electricity flows through a conductor. If one conduit material has a higher impedance than the other, the conductors in that conduit will experience a greater voltage drop. This can cause equipment to malfunction or not operate at all. Thirdly, ground fault current. In the event of a ground fault, the fault current will flow back to the source through the grounding system. If the parallel raceways are not of the same material, the ground fault current may not be evenly distributed between the raceways. This can lead to excessive current flow in one raceway, which can damage the equipment and create a safety hazard. Fourthly, mechanical stress. As mentioned earlier, different materials expand and contract at different rates in response to temperature changes. If the parallel raceways are not of the same material, the differential expansion and contraction can create mechanical stress on the conductors and their terminations. This stress can lead to loose connections and potentially cause arcing or other electrical faults. Fifthly, code violations. Non-compliance with National Electrical Code Section 310.4 is a code violation which can result in fines, penalties, and potential legal liability. In addition, it can void the insurance coverage for the electrical system. Given these potential consequences, it is essential to take National Electrical Code Section 310.4 seriously and ensure that all parallel raceways are of the same material and have the same physical characteristics. This will help to ensure the safety, reliability, and performance of the electrical system. To further enhance the understanding of National Electrical Code Section 310.4, it's beneficial to examine some frequently asked questions or facts related to this topic. Firstly, question. Does National Electrical Code Section 310.4 apply to equipment grounding conductors? Answer. Yes, National Electrical Code Section 310.4 applies to equipment grounding conductors, or EGs, as well as to phase conductors and neutral conductors. If equipment grounding conductors are run in parallel, they must also be installed in raceways or cables of the same material and have the same physical characteristics. Secondly, question. Can I use different sizes of conduit for parallel conductors? Answer. No, National Electrical Code Section 310.4 requires that all parallel raceways be of the same size, as well as the same material. This is to ensure that the conductors are evenly distributed within the raceways and that the impedance of each raceway is the same. Thirdly, question. Can I use different types of fittings for parallel conduits? Answer. No, National Electrical Code Section 310.4 requires that all fittings used with parallel conduits be of the same type and material. This is to ensure that the electrical continuity of the raceway system is maintained and that there are no potential points of corrosion or failure. Fourthly, question: what if I can't find the same type of conduit for all parallel runs? Answer: in some cases, it may be difficult to find the exact same type of conduit for all parallel runs, especially in older installations. In this situation, it is best to consult with a qualified electrical engineer or inspector to determine the best course of action. They may be able to recommend an alternative solution that complies with the National Electrical Code and ensures the safety and reliability of the electrical system. Fifthly, question: does National Electrical Code Section 310.4 apply to direct buried cables? Answer: yes, National Electrical Code Section 310.4 applies to direct buried cables as well as to raceways. If parallel conductors are installed as direct buried cables, they must be of the same type and have the same physical characteristics. This is to ensure that the cables are evenly exposed to the soil and that there are no potential points of corrosion or failure. By addressing these frequently asked questions, a more comprehensive understanding of National Electrical Code Section 310.4 can be achieved, leading to safer and more compliant electrical installations.